All right, guys, so notes 1, 2 here, we're going to talk about a lot of things. We're going to talk about the IVT, which is the intermediate value theorem, end behavior, extrema, like max and mins, and average rate of change, which we'll call AROC. So not a nice title today, just a whole bunch of things we're throwing at you there. So end behavior, I think you guys are pretty familiar with that concept, but we're going to do the notation a little differently this year. We're going to start moving towards all the calculus notations. So we're going to use limit notation. So we're going to do just a couple of end behaviors. So let's look at, say, my function is f of x equals x squared. Do you guys know what the ends of that function are doing? Yeah, where are they going? Both up. And you maybe wrote it as x approaches infinity, y approaches infinity. Is that what you're used to? Okay. So the way we're going to write it now is the limit. So you can just let me write it, and then you can jot down the notation of f of x as x approaches infinity equals infinity. So the limit of your function, which means what is it approaching as x goes towards infinity, it is infinity. So that's the right side as x approaches positive infinity. We can also write it for the left side. So limit of f of x as x approaches negative infinity is also infinity. And when we're going through notes, guys, if I ever go too quickly or you can't read something or you want me to go back, if I scroll away from something, just shout it out, let me know, okay? All right, so let's look at another one. Let's say g of x is equal to negative 5x to the 5th. All right, think through what the ends are doing. Do you know what they're doing? Okay, try to write it with the limit notation. I'll give you a second to do it, and then I'll put it up here for you. Check with your neighbor, glance over there. Do you guys have the same thing? No? Okay. Well, let's see who's right. So guys, first the graph, something like this, right? The right end's going down, left end's going up, because that negative in front. So our notation. Limit of f of x, oh, sorry, it's g of x, it's not f of x. I always forget when it's not an m. So the right side is going towards negative infinity. And then the limit of g of x, yes, as x approaches negative infinity, is infinity. All right, how are we doing? Okay. Not that bad on the notation? Okay, good. That's the end of end behavior for the day, okay? Moving on. I know you guys know what it all means. It's just getting used to that notation. And you're going to see this all throughout the year. We actually do a whole section just on limits and evaluating limits. So this will become very familiar to you. All right, next is the intermediate value theorem. And we will reference that as the IVT. All right, it's a bit wordy, so let me write the theorem down. You guys can jot it down, and then I'll go back and explain all the pieces of it, okay? So just bear with me as we get through the wordiness. All right, if f of x is a continuous function, and a is less than b, and there is a value n such that n is between f of a and f of b, then there exists a c such that a is less than c is less than b, and f of c equals n. Okay, again, I will explain, but let me give you a minute to jot it all down. Okay, you want an explanation or no, we're good. This makes perfect sense. It makes sense with a picture. Let me show you. But yeah, it is interesting. Some of these theorems, the way they come about, you're like, but this is when people just sat around and thought about this stuff all day. All right, we're going to draw a little picture. Okay, so we have some sort of function, f of x, and then we have a is less than b. A and b are x values, so I'm going to put a right here on my, well, I'll just label that a on my x-axis, and then b is somewhere over here, because a is less than b. It doesn't have to be on the positive side of the x-axis, just that's where I'm drawing it, but just a has to be less than b. Okay, then it says there's a value n that's between f of a and f of b. What are f of a and f of b? Y values, right? Okay, it's the y value at these x values. So I'm going to call this point down here, we'll label this guy a, f of a, and then I'm going to put a point somewhere up here, and I'll call that b, f of b. And I'm going to connect those, okay? Some sort of function. It says it's a continuous function, so I'm going to draw that in. With me so far? Okay. Then there exists a c such that c is somewhere in between a and b. So I'm going to say c is maybe right here. It just has to be anywhere in between a and b. Doesn't matter where, just in between there. And then they tell us that f of c is n. So I'm going to label that point c, f of c. And this would be a y value of n. I'll let you draw it all and then I'll explain a little more, okay? Okay, so we're saying that if you have some function that connects these 2 points, with it being a continuous function, it would have to cross through this y value and x value to get there. That's all this whole function is saying. We're going to use it a lot with the n or this other value being the x-axis. So I'm going to ask you, like, does f of x equal 0 between these 2 x values? And you're going to say, oh, well, this one was negative, this one was positive. It had to go through 0 somewhere in there. Okay? That's where this is leading us. Questions? Yeah.
So we find the value of n through the IVT.
Mm-hmm. Or it's given to you and it'll be asking, does the function like go through this n value? You'll have numbers in an actual problem. It won't be all letters. Okay? So let's try one and let me show you how you answer a question like this, because obviously there's a lot going on here. All right, so first one. So let's say you are given f of x, which equals x squared plus 2x minus 3. We want to know, does f of x equal 0 on the interval -1 to 3? Yeah, go ahead, just take it back. All right, so we've got a function. Does this function equal 0 on this interval? So what you need to figure out is, will the graph cross the x-axis on this interval? You can check it by looking, we can start with the endpoints. If one of them gives me a negative value and the other one gives me a positive value, then I know the graph has to go through 0. Does that make sense? Like, you can't get from negative to positive without crossing through 0. Okay, so let's first just kind of off to the side here, plug in these values. What would f of -1 equal if you plug that in? Anybody think they have it? -4? Yes. Okay. What about f of 3? What is that going to equal?
0.
No. It is 12, yes. Okay, so we go from a negative y value to a positive y value. So yes, we know this is going to cross the x-axis. We don't just get to say that, though. There's a formal way you have to go through using the IVT. So let me show you those steps. It's just a list of bullet point steps that you're going to go through every time, okay? So the first one, the only way this works is if this is a continuous function. Do you think f of x is a continuous function? Yeah, what is that a graph of? Parabola, right? Parabolas don't normally have asymptotes, jumps, anything like that happening in them, okay? So first you start by stating f of x is continuous. All right, next we're going to say one y value is less than 0 and the other is greater than 0. So this time it worked out that f of -1 is the negative value. So I'll say f of -1 is less than 0, which is less than f of 3. Be careful when you do this step because the negative x that you're plugging in doesn't always give you the negative y. So sometimes they're going to be, in a different order. So just pay attention to those values. Make sure you're actually putting the -1 less than 0 and the +1 greater than 0. All right, your third bullet point. So there exists a C -1 is less than C is less than 3. So that's back to talking about your x values. Okay. Fourth one, such that f of c equals 0. So we're saying, yes, this function will equal 0 at this point. And then the last piece is by the IVT. So yes, you have to do these with these bullets, with this wording in this manner. Now, the good news is for every problem that we're going to look at, the first, the fourth, and the fifth bullet are all going to be the same. So those should be like free points. Even if you totally mess up what's going on with the function, you're like, well, it's an IVT problem. I know 3 of the 5 points. You should be able to write those down. Okay, and then in the middle, the first one here is talking about the y values. And then the second one is talking about the x values. Okay, so that helps you remember it a little bit.
Sorry, could you just plug in the 2 numbers there and then get the other 3 point? Like, all you did for the second step was put the numbers from the brackets into that format.
Right. That's what you're doing, is you're saying like which y value is less than 0, which y value is greater than 0.
Oh, okay.
Yep, absolutely. Other questions on it? Okay, let's try another one so you guys can try to do the format. So the one I gave you first, I actually gave you the equation of the function. Sometimes you'll just be given a table of values. So that's what we're going to do in our second one here. So you're given this lovely table with some x values and some f of x values. Move it up a little for you guys. So just jot down that table. You do not need to like come up with the function that goes with this at all. You can answer the whole thing just from the table. So your question, does f of x equal 0? On the interval -3 to 1. I want you guys to try this one. Can you do your 5 bullet points? And you can look at the one you just did, it's okay.
So automatically we could just write 1, 3, 1, 4, and 5.
You what?
Automatically we could just write the first 4.
Yeah. You know what they're going to be, right? Now, when you get into calculus, you might be asked something other than does it f of x equal 0? It could be a different number, but same idea. Once you and your neighbor are done, check and see, did you do it the same way? Are you okay? That's not a face that says you're okay.
Zero. What I did is I got.
Got it?
That's why mass X but it could be a for this.
The building stuff.
At least agree, if nothing else, right? Yeah. Safety in numbers.
Just by doing these. I mean, this by
I don't know what the
It doesn't make sense. Yeah, guys, when you're doing, especially one like this, make sure your inequalities make sense. Don't tell me a negative number is bigger than a positive number. So double check that.
I just wrote it and then it realized that it makes.
We'll always make the negative one smaller than the positive one. You can do that. Give me another minute here. Make sure we're okay. I will go through all of it. Don't worry.
So,
this is
like this?
probably
That would be a really annoying way to lose a point.
And it happened.
Oh, I can totally see that happening.
Oh, yeah.
I mean, it just happened.
Right one.
And now you know. Now you've seen it.
So I was literally just sitting there, I was like, wait a second.
And the IVT question like this on your assessment is, and there's no tricks, but you do have to know, you know. So it should be like an easy one, but you have to take the time to
I keep on
know
thinking
it.
they're gonna throw something at us until like completely blow it up.
No, I am not here to trick you. I promise.
It's almost too straightforward.
You're not wrong. It's such that we're very proper.
So to exist
Can we do the three dogs and here's like that? We do the three dogs.
We usually use those for therefore in here, so I know.
I knew there was
All right, guys, let me write it here. Okay, so first one should be a freebie, right? F of x is continuous. Oh no. So it's given because we don't know what the function is, so you need to know that it's a continuous function. You can't just figure that out, because by looking at the table, I mean, what if it's just 5 dots plotted? Like, I don't know that that's continuous unless someone tells me it's a continuous function. Okay, so that's step 1. Step 2 is actually f of 1 is less than 0 is less than f of negative 3. Or if you were like, I need to write f of negative 3 first, then you say that's greater than 0, which is greater than f of 1. I would take either of those. Do we get where that's coming from? Because those are the y values. We need the negative y value to be less than 0. Okay. Third one here. So there exists a c negative 3 is less than c is less than 1. Again, make sure those go in order. Negative 3 is smaller than 1. Okay. All right, then your last 2 freebies. Such that f of c equals 0 by the IVT. Okay, how do we do? Yeah, question?
So step 3, just repeating what's on the x as an interval.
Mm-hmm. Yep, you're just saying c has to be somewhere on the x interval. Yep. Yes, we're seeing it. Yeah, it takes a minute for this to kind of marinate.
Is the number like a 0.3? Is that you have to be between the two like outer x's?
Yes. Now in this one, did anybody pick different x values? Did anybody say like between 0 and negative 1? You could have, because that's where you can see it's a positive y value and a negative y value. You could certainly like change it up as long as it covers where it's going to cross the x-axis. I think it's easier to just use the interval you're given, but you don't have to in this case. Okay. Does that answer your question, or did I make that worse?
So like when you do the x's,
Mhm.
basically it's gotta be, you know, the negative value on the left and then the positive on the right. Okay.
Or you have to flip your inequality signs.
Okay.
Yep.
Thank you.
Yeah. Just make sure you write a true inequality. So guys, these questions, you know, they take a little time, but there's really no tricks there. I'm not going to surprise you with anything on this on the assessment. It's going to look just like this. And if you can answer with your 5 bullet points, you're going to get the question. Okay. So these should, even though they look kind of scary, they really should be the easier question on the assessment.
Are you gonna put one where it's like you have to solve it and then it actually doesn't end up working out?
I will not give you one that is not true. Okay. Yeah.
So if it doesn't say like if it's given like the continuous, do you just say like unknown?
So if it's like a table or something like this, that will be given to you. If I give you the function, you have to use what you know about the function. Is it a continuous function or not? Okay.
Wait, but so it doesn't, but you said the first one is always true.
It has to be continuous to be able to do this, so you should be fine. But I'm saying, like in the second one, you know how I said given f of x is like I told you it was? In the first one, you needed to think about it that, okay, that's the graph of a parabola. Yes, that's continuous. Okay, yeah. Does that make sense? Okay.
So it's possible that it's not continuous.
I mean, if it's not continuous over that interval, yes, you could not do this. Because the IVT does not hold true if it's not a continuous.
And then what would you give that?
You just say, no, I can't do this. I'm not going to give you one. First one should be a good thing. Just write it down. This is late. You made a mistake. This doesn't work. Okay. Other questions on the IVT? Okay, we'll revisit this. You'll get to practice this again in a warm-up next class. Keep working on it. But just look over those 5 bullet points. All right, let's move on to, all right, max and mins and all that good stuff. I'll call this graph analysis. Okay. I'm going to make a little sketch here. I'll label all of these points once we get there. All right, try to sketch that graph, guys. Can you read all the points? Can we see it okay? In the back? It's 5, 4 over on the right. 1, 2, negative 1, 2, and then negative 4, negative 5. make sure everybody has it written before I start. All right, guys, we are going to identify intervals on this graph where it's constant, increasing, decreasing. Then we're going to look at the maximum and minimum. Those are the extrema. And we're going to talk about what a secant line is. So first, let's do our intervals. So we're going to look at constant, increasing, and decreasing. So to answer these, the answer you're giving me, the interval, is always the x values over which this occurs. The constant, increasing, decreasing, that's talking about what the y value is doing. Okay, like the y value is constant, where does this happen? Okay, so guys, between what x values is this constant? Yeah, Aiden or Aiden. Yeah, -1 to 1. And that's the only little stretch on this one. Now, when we do these intervals, you're safe to just do soft brackets. The reason for that is at the endpoints, it's technically not increasing, decreasing, or constant. Like that's where it's changing. So you can just go ahead and use the soft brackets for all of these, okay? All right, increasing. We're gonna have a couple of intervals here. So where is this increasing? Yeah, go ahead.
Just one. -4 to -1, and
Okay.
then maybe the second.
Yeah, go ahead for the second.
1 to 5.
Perfect. So -4 to -1, and then do you guys remember the union symbol? Okay, and then 1 to 5. Good. So if you use the hard bracket, that means that point is included. So like if I look at this dot right here at 5, 4, at that specific point, is it increasing or decreasing, or we don't know, it's just changing. So that's why we use the parentheses instead of the brackets, okay? All right, and we've got a couple of decreasing intervals, yeah. 5 to infinity, that's the second one, good. Where's the first one? Yeah. Good. That one's tough because you're like looking way up high, but it is decreasing. So the x value over there is -infinity to -4, and then again 5 to infinity. So remember, all of these are x values. Yeah. Yes, yeah, so the way we're writing our intervals, you always go from the left side of your graph to the right side. That's a good question. Anytime you're doing interval notation for anything, they have to be in order like that. Okay, so let's talk about maximum and minimum. So you might see a couple different types of maximums or minimums. Sometimes I'll ask you for the absolute max or min. Do you think this graph has an absolute max or min? No. Good guess, guys. Didn't sound real confident. No, it doesn't. It would be the absolute highest point on the graph, meaning nothing else could ever go higher than it, or the lowest. So like a parabola, that has an absolute minimum. Okay, but when the ends of the graph are going opposite directions, you don't have that, okay, because it's going to go to infinity and to negative infinity. So we're looking for a relative maximum. That has to be the top of a hill, okay? The points on either side of it have to be lower than the point you're looking at. So do you guys see a maximum on here? Yeah, where is it? Yes, and the way we write this, I know this is going to seem weird, the maximum value itself is actually 4, and it happens at x equals 5. When you get to calculus, the max and min part can be asked in a few different ways. If you write it this way, you're safe no matter how it's been asked, because you've covered what the value is of the maximum and where it occurs. Okay. Is everybody okay with why -1, 2, why that point right there is not a maximum? Do we see it? Because the points to the right of it are actually at the same level, so it's not like the top of a hill, okay? All right, so we have one minimum, one relative min, yeah.
If you, if you have two tops of the hills, do you only focus on the one that's higher?
No, good question. So let's say there were 2 hills, different heights, or the same height, it doesn't matter. If I'm asking for all the maximums, you just list all of them, if there's more than one, okay? You don't just list the heights. If it happened to be then absolute, and I asked you about that, then you list that there. Another question there? Oh, yes, tell me, what's the minimum? Perfect. Okay. Good with our extrema here. Okay, and then one last thing, we're just going to draw it real quick because it's going to come into play later. Do you guys know what a secant line is?
Oh, I remember having that.
Geometry. Is that a happy flashback or no? Painful? Looking back. Not in the moment, but looking back. Okay. Secant. S-E-C-A-N-T. Yeah. My C looks a little weird. Do we know what a secant line is? No, we do not. Okay. Do you know what a tangent line is? Do you guys remember that? Okay. What does that do? 1 point. Yeah. Okay. You're used to it with circles and geometry, but it could be any graph where it just touches at 1 point. A secant line touches in 2 points. So you, on your circle, you would have the one that, you know, goes all the way through the circle. So I can draw a lot of different secant lines on here. You don't have to connect any of the 2 points, but like that would be a secant line in that little interval because it would cross through those 2 points. Obviously, if I extend that line, it's going to cross more than 2 points of my graph, but that's a secant line. So it just intersects. The graph at 2 points. Okay, guys, the last thing we have today is called average rate of change. The what, huh? Average rate of change. We will call it AROC for short.
Which space does this part take up?
I have it as like half a page, but I wrote decently large, so it's not too bad. All right, the AROC, or average rate of change, is the slope of a secant line. So see, we had to know what a secant line was first. So let me give you a picture here. So I'm going to draw a little graph. This isn't necessarily a parabola, okay, it's just my function. I'm going to put a couple points on there. That's A, f of A. Over here is B, f of B. If I connect those two, that's a secant line. Okay. If I want to find the slope of that secant line, the red line on there, going back to basic slope that you learned forever ago, how could I find the slope of that line? Yeah.
So y minus y1 no, y2 minus y1 over x.
Yes, exactly. The slope formula you've known forever. I'm going to just use the function notation instead of the y's. So I'm going to say f of b minus f of a over b minus a. Okay, you guys see it? So it sounds like some new confusing concept. It is not. It is basic slope that you've known for years. Okay. All right, guys, one more example and then we're done with those, okay? All right, so you are going to find the average rate of change, AROC, and you're given this function, f of x equals negative 2x squared plus 4x plus 6 go on the interval -3 to -1. So looking at the formula, do you know A and B? Yes. What are they? What do you think A and B are?
Negative 2 and 4.
No. You're right if I was asking about the quadratic equation and all of that. Yes. Yes, -3 and -1. So guys, these right here, whatever interval you're given, that's like the endpoints, the points you're going to use for the secant line. So this is your A and this is your B. Remember, this is the formula we're going to be using. So can you find f of A and f of B? See a few nods. If I want to find f of A, that's really f of -3 And then this is just function notation. You're substituting in the -3 into the function. Oh, you're ahead of me. Good job. -6. Try again. There's a lot of negatives to be careful of here, okay? Remember, do your exponents first. So -3 squared is going to give you +9 times -2. So we have -18 minus 12 plus 6. What do we get? -24. Oh, negative. Okay, then we also need f of b. So f of -1. Yes. Okay, we're good on all the pieces. All right, now we're just going to do that AROC formula. So f of b, which was 0, minus f of a, so minus -24. You can just write plus 24 if you want. Over b minus a, so over -1 minus -3. So my numerator is 24, my denominator ends up being 2. So the average rate of change of this secant line is 12. Okay. Does that make sense? We okay? All right. Questions on anything, guys? Good job. Wasn't too bad, right? Okay, we've got about 20 minutes left. I'm just going to give you time to work on your math space in case there's questions that pop up while you're working on it. So go ahead and get out your laptops. Let me assign it to you real quick. I don't think I've done that yet this morning. I got it.
You already know. Okay, first or better. You know, like, look at
Oh, you're not.
Sorry, guys, it's coming.
I was like, I realized that, like,
I did. I put relax in. Next word.
I use pencil, pen, highlighters.
Okay, homework should be there on math space.